Hello, ladies and gentlemen. Today we are asked to find the equivalent resistance of this network. In other words, we have to find the net resistance between points K and L. Let's get started. So, first thing I'm going to do is I'm going to identify nodes and points that are equivalent to K, and then nodes and points that are equivalent to L. So let's start by labeling K and L by green and red colors respectively. Now the nodes that are equivalent in the case of K to this point are going to be this node and this node, right? Because there is no resistor, no circuit element here, right? So these two nodes are going to be equivalent to point K. And in the case of L, this is going to be the node that's equivalent to L because there is nothing between this node and the point L. Okay, now what are the points on the resistance that are equivalent to K and L? Well, so this point, this point, this point, and this point are equivalent to point K because there is nothing, right, in here. They're all continuations of the same wire with resistance of 0. And then in the case of L, these points are equivalent to L. Is there any other nodes that are missing? Well, yeah, this one, right? So let's just label it with different color. Let's call it blue. So this node is equivalent to the point here, here, and here, right? So you obviously see this 2 and 4 ohm is probably likely to be in series. Let's redraw this circuit in a simpler manner. Let's find the equivalent circuit for this one. So I start from point K and I hit 12 ohm, I hit 4 ohm, I hit 2 ohm, and I hit 6 ohm resistors, right? And then from this two end up converging here and then meet with 3 ohm resistors. These two converge together at this point and then meet it's 3 ohm meet 3 ohm resistors at the point L. And same here, it goes to here and then has to converge with these two resistors at point L. So what is the equivalent resistance? Well, the equivalent resistance is going to be this. Why? Because you start from K, you hit 6, and from 6 you go to L. This does the job. Here you hit 2 ohms, you pass through 4 ohms, and you get to the L. Okay. Here you have 12 ohm and then a 4 ohm, right? 12 ohm and a 4 ohm, they converge, and then they go pass through 3 ohm, and then it hits L. So this is effectively your equivalent circuit. So solving this circuit is the same thing as solving this circuit, but this one looks much simpler. Now, these two resistors are in parallel, then whatever this one is going to be in series with this. These are in series, and then all these three in parallel with each other. So let's get started. So the resistance of this two resistors will be just, they're in parallel. So it's going to be R1 times R2 divided by R1 plus R2, right? Which gives us 3 ohms. What about this one? Well, in this case now you have 3 ohm in series with this 3 ohm, so this is 6 ohms. What about this one? You have 2 ohms plus 4 ohm. This gives you 6 ohm, and this one is a 6 ohm, right? So now to find the net resistance between points K and L, we just have to consider this, and this to be in parallel. When you have 3 resistors in parallel, what is a net resistance? Well, reciprocal of a net resistance is going to be the sum of individual resistors that are connected in parallel. In this case, 6 ohm here, 1 over 6, 1 over 6, 1 over 6. And this is just going to be 3 of 1 over 6 is going to be 1 over 2 ohms. And if we invert this, we end up getting 2 ohm for the net resistance in the circuit. I hope this is clear, and the answer to this question is going to be 2 ohms. The net resistance between point K and L is 2 ohms. Thank you.